Okay, how's everyone? I'm on page 698 looking at example 1. And on example 1, you'll see an A and B. So I'm going to look at part A first. Um, you can see that we have multiplication of some fractions, and these are basically numbers and variables up here. These are all monomials, right? They're one term. This is a monomial, this is a monomial, as are these two. So just a quick refresh. We actually know how to do this. Remember, when we are dividing, we are able to cancel. Exponents by subtraction. Now, even though that there's two fractions here, there's two ways to do this. The first one is to just times all the top together, and then times all the bottom together to get your answer. And I'll show you what I mean. We could say 3 times 1 is 3. Then we could say there's 2 r's, right? R squared. There's an x in there, and there's a t to the 4th. Okay, so we could just multiply the top together, which is what I've done. And we could also multiply the bottom together, right? 9 times t cubed, and then there's an r down here too, right? Because it's timesing, right? So timesing. And then from here, then we could look at our answer, and we could start to simplify by reducing. So 3 over 9 reduces to 1 over 3. Do we really need the 1? Nah. So when we write our answer, I'll go ahead and take the 1 out. But for now, 3 over 9 reduces to this. Do you see how there's 2 r's on top? There's 1 on bottom, right? And it's like we say 2 minus 1 is 1. So we got 1 r left, right? Because we're dividing, so we cancel by subtracting the exponents. And it goes on top because that's where the larger exponent is. So here we have 3 t's and 4 t's. So 4 minus 3 is 1. And it also goes on top because, once again, 4 is larger than 3. And the x can't cancel with anything, so the x stays on top. Okay, so once again, as promised, I'm going to write my answer without that 1. Our answer could be RTX over 3. Okay, so that's the way that most of us kind of think about this the first time, is times the tops and times the bottoms. However, I'm also going to position you to be able to cancel things right away. Just a quick reminder that when we times stuff, that this becomes basically a giant fraction bar. See this? Like, this is one giant fraction. So what we can do before we times is we can start canceling right now, and that's what I'm going to do. 4 t's, 1 t, there must be 1 t on top, right? 2 r's, 1 r, right? There must be 1 r on top. There's an x up here, there's none down here, and 3 divided by 9 is 3, right? So you can see we get the same answer just by kind of canceling those things as we did over here. Now, also a reminder, RTX and TRX are exactly the same because they're timesing, right? 2 times 3 times 4 is the same as 4 times 3 times 2. It doesn't matter what order we multiply. Okay, so that should be kind of old stuff. We're going to use it to springboard us into what we're doing now. So go over to 701. Okay, we're going to multiply and divide these next couple of days here using binomials and trinomials. So if you look up in 15, right, they're not monomials anymore. I mean, 9 and 3 are, but these are all binomials. We have 2 binomials up here and 1 down here. So once again, guys, we could do what we did up here in the first problem. I don't know if you can see that still, where we times everything across. But what you're going to see me do is we're going to cancel stuff right away, especially with binomials and trinomials. It's much, much easier to cancel them when we see them. So if you see multiplication, guys, remember, it's basically giving us one giant fraction, right? Because we're just going to mush them together anyways. Let's cancel. I see this t minus 2 down here? I'm going to cancel with that t minus 2, right? You see this 9 over 3? What's 9 over 3 reduced to? 3 over 1. So I'm going to have 3 times, now the only thing left up here is, so I'm going to say t plus 2. And it goes over 1, right? 9 divided by 3 is 1. Do I really need to put it over 1 here? No. So we can leave it as this, and that's our answer. All right, so again, you can times these right off the bat, but my suggestion is to cancel stuff, right? Try to cancel stuff right away. All right, so that was 15 on 701. Let's go back to 698. And let's look at the guided practice 1C. So this is very similar to what we just did, although now you see trinomials in here, right? This is a trinomial, this is a binomial. And I want you to look at this binomial when it's compared to this one on top, or these two. Does anyone notice something different? This binomial can be factored, okay? Just like this trinomial can be factored. So what we need to do is we need to expand, all right? If you ever see trinomials in division or multiplication like this, expand them, right? If you see binomials that can be factored, expand them. Remembering that factoring and expanding are the same thing. I'm just using a different verb there. All right, so let's go ahead and factor this top thing. I'm going to put it in parentheses, okay? I'm going to bring this down. Minus minus is plus minus. First term is y and y. Factors of -4 that add to -3. I think it's a -4 and a +1. Is that right? Yes. So let's bring the -4 here and the +1 there. Remember, this is still over this binomial, y plus 5. Okay, so all I've done is I've expanded this numerator. I factored it into y plus 1 and y minus 4. And the reason I'm doing that is because I want to cancel stuff, right? We're trying to cancel things, particularly other binomials. So I got y plus 5 up here. Now on the bottom, this one looks like it can be factored, and it looks like it can be factored a pair of ways. The only way it can be factored is greatest common factor. It looks like it could be difference of squares. It's not, because 4y is not perfect, right? The y is not perfect. So greatest common factor here is a y, you guys. I can take a y out, right? Take a y out, and that leaves me with y minus 4 inside. Okay. And remember, if you want to check your greatest common factor, just multiply it. Y times y is y squared. Y times a -4 is -4y. Okay, so this is the factored version of that. Okay, so now that we've expanded things, let's cancel. I see some things already. It looks like this y minus 4 and this one. Remember, this is a giant fraction, right? When we're timesing, this is like one giant fraction, so we can just cancel them wherever. As long as there's one on top and one on bottom. I got a y plus 5 over here, and I got a y plus 5 down here. Now, the last thing here is we have this binomial, which is y plus 1. And it goes over, see this y that we factored out? It goes over here. And a lot of kids want to try to cancel this, but the problem is this 1 doesn't have a y, so we can't actually cancel it. This is our answer. Okay, this is our answer here. All right, guys. I want you to try a couple of problems for me. Okay. Go to page 701. All right. I want you to try number 17, number 19, which should look similar to what we've practiced. And then listen, I want you to try this one. It's on the next page even further than that. It's number 55, and listen closely. You will see a pair of fractions that are multiplying, and each part of the fraction, each top, each bottom, they are all trinomials. All right, so your hint on 55 is to expand everything, right? Remember how we expanded this and this? Well, on 55, you're going to have to expand all 4 parts of the 2 fractions, okay? If you have any questions, let me know. Otherwise, good luck.